So let's review naming acids. Way back when we did naming, we learned how to name acids, and now we haven't done it since, November. They were the endings, ik and us. Okay? If you name your ionic compound and it normally ends with "ide," if it's an acid, it will be hydro something ic acid. If it's ate, it'll become something ic acid. If it's ite, it becomes something us acid. So if you recall, the "ide" ending came about because you had an acid from the periodic table. The ate ending is that polyatomics that you're used to, sulfate, nitrate, chlorate, carbonate. The ites then are all one less oxygen, and then those end in us for acids. So if we look at these three examples and try to name them, okay, HBr, H2CO3, and H2SO3, we'll run through the technique again so that you remember. Now, one thing you'll see in common with all acids is they all start with hydrogen. Okay, when we get into the definitions of acids and bases in terms of chemically, not just their characteristics, you'll see this H and how it basically applies. So it's some anion with a number of hydrogens needed to balance out the charge. In terms of naming it, if you name this just the way it is, hydrogen bromide, because that's the bromine ion, the fact that this ends in "ide" tells us how to rename our acid. "Ide" then becomes hydroic. Okay, so this is normally hydrogen bromide. It will be changed into hydrobromic acid. So those two come on and the hydrogen goes away. This one would have been named hydrogen carbonate. Okay, that's carbonate. So if you have carbonate, the ate ending comes off, and ate is replaced with ic acid. So that's carbonic acid. This guy, this would be hydrogen sulfite, because sulfate is SO4, and this is one less. So if this is sulfite, ites becomes us acid. So we have to run through and review this again. I'll put a list online of the polyatomic ions again that we'll be using so that you can review and rememorize those. You've got to memorize these rules. Ide goes to hydroic, ate goes to ic. I ate something icky, and then ite goes to us. Luckily, there's no fancy way to name a base. Okay? Bases will predominantly all have hydroxide groups. So if you look at all these names and the formulas on the screen, they all have OH, which is your hydroxide group. And then you just create formulas and create names neutralizing charges just like we've done a billion times. So magnesium hydroxide, for example, you get the magnesium ion, you get the hydroxide ion, and then you crisscross to balance out the charges. Now, hydroxide needs to be in a parenthesis to show that you need two of the entire thing. Same thing will happen with calcium. Calcium is plus 2, OH is still minus 1, crisscross, CaOH2. If we did lithium instead, lithium has a plus 1 charge, so it's going to neutralize just 1 to 1, and that's lithium hydroxide. So bases are super easy. They're always with hydroxide, and then it's just a question of balancing out the charge. So number 4, the NH4OH, that's ammonium hydroxide, because that's the ammonium ion. So you just name each piece. Number 5, Sr is strontium, so that's just strontium hydroxide, and Ra is radium, so that's just radium hydroxide. So each time you just name each component of the hydroxide group, and that's all naming bases is. That's it for this one. Go ahead and do the form, and have a nice night.